In this lecture, we'll go over how to use moves, DMOVs, BMOVs, and FMOVs in GX Works 3. So we'll start with the basic one, which is a move instruction, and we'll go put an SM400 because you need something in front of an instruction to execute, and then we'll do move D2 to D3. What this would do is move 16-bit or D2 into D3. And if we download the changes and say yes, changes are done, and as you can see, whatever is in D2 is in D3. So we'll go bring up D2 in our watch and put 5 in there, and we should see a 5. So that's how move works. It only moves a 16-bit or 2 bytes or 1 word into the specified word. Now we'll just disable it and we'll use a double move instruction. So if you do a double move, like it says, it's called double move because you would move 2 registers, and you need to make sure you specify your next register should be after the occupied space. So D2 double move would occupy it would move 2 words starting from the first word, so D2 to D3, and it would move it to D4 to D5. We'll download the changes, and now if I bring in D2 and D4, also in the watch window you can change the type. So instead of word, we'll do a double word. So if I put in 25, you would see 25. If I put in 65,000, it would put a 65,000. So that's how a double move works. It's pretty simple. Now we'll do an F move. What this does is, with F move, it would transfer 16 bits of block data in and fill up with a constant. So if I want to clean up, in our case, from D2, D3, D4, and D5, if I do an F move D2, and my constant would be K0, but I need to specify the length. So that would be 2, 3, 4, and 5. So length of 4 and fill with K0. I think I missed something. K2, K0 for the length of K4. Let's try it again. Okay, the only thing I had incorrect was my K0 has to be in front, so the constant you're trying to fill in with needs to be in the front. And in the middle would be the instruction or the memory area where you want to start filling 0 with, and K4 is the length, so it's going to fill 0 from D2, 3, 4, 5, and 6. As soon as I send this, all these would be 0. And there you go. All of those are 0 now. Now we'll turn it off. Now we'll do a block move. As the name specifies, block move is basically a bigger version of DMOV. You can specify a length of block, so you could do blocks of 5, 10, 15, 2, 4, I mean whatever you want. It's not specific, so you could just tell the length of the block you want, and you can move the whole chunk of data from a set of memory to the other set of memory. It's really useful when you're moving part information from one station to the other. You would do a block move, and you'd move all the stuff that is related to the part. So if you do a block move, we'll do D2 to D12 for a length of 10. So here what it's going to happen is, it's going to move D2 into D12 for a length of 10. That means from D2 to D11 would be moved to D12. Now keep in mind, it does not clear out D2. Everything in D2 still stays. So if you want to clear out D2, then you would have to either do an F move underneath it, so it clears out D2 after the move, or you do a swap. But with the swap function, what it does, it basically swaps the memory information between the registers for the length. So here what we'll do is we'll bring in D12, what we'll do is D11 and D21. So if I do we're on the watch. So I also want to bring in okay, we have D2, I want to have a D12 so you can see. Okay, there we go. Okay, so if I put a 2 here, you're going to see 2 and 12, and if I put a 55, I'm going to see 55 and 21. That means that it's moving everything between D2 and D11 to D12 and D21. So that's how a block move works. We'll zero that out or turn it off. And the next one would be EMOV, which is used when you're trying to move real numbers. So if I do an EMOV, that's basically moving a single position real number. So that's all about it. It's still a double move, but you typing in E would at least help the other guy know that, hey, this is a real integer, and you could also see the value in real format. So let's try it out. So we will do an EMOV D2 to D4. If you see, when I did an EMOV, my value in D2 and whatever is in D3, they kind of made up into a real, and it's showing up here. We'll send it, and we'll put a value that we can recognize. Since I have D2 up here, all I have to do is go to the side, change the data type to a floating single, and here what we'll do is I'll put a minus 2.5. There we go. It moved minus 2.5 to D4. So that's all about the moves in Mitsubishi. There are a bunch of other moves that you can use, and you can swap stuff. There are byte moves as well, and things related to strings, which would be we'll go over strings in the next couple of lectures here soon. So, all right, thank you.